A water molecule. A salt crystal. Polar charges on the water molecule. It has a positive end and a negative end. Sodium is positive, chloride is negative. Look at the positive ends surrounding the negative chloride, and they scoop it away, they take it away. Here come the negative ends of the water, and they grab a positive sodium and take it away. And then they surround it. You see the positive ends of the water surround the negative ion, and the negative ends of the water surround the positive ion, and off they go, and they keep doing it, and it goes on and on and on until all the ions are separate. Yes, they're all spread out in the water. Does this ring bells? Okay, excellent. So this is what's happened here. We've taken some sodium nitrate and we have dissolved it in the water, and now we have free floating ions. We have Na plus, which is aqueous, and we have NO3 minus, which is aqueous. We can write them together and write it as aqueous, and it still means that they're separate. Okay, if we write aqueous. Potassium sulfide. What do we know about potassium? What kind of element is potassium? It is an alkali. Therefore, potassium sulfide is soluble. So it's aqueous. And when it separates, it's going to separate into K plus and S2 minus, but for every one S, how many Ks do you have? You have 2 Ks. So you can see that in the solution. We have 2 Ks for every 1 S. 2 Ks for every 1 S. 2 Ks for every 1 S. Now I can toss those together. And in theory, my products would be, I would take my outside ions, Na, actually I should do a different color. I would take my Na and I would put it together with my other outside ion S, and I would end up with Na2S. What do you know about Na2S, solid or aqueous? Na2S. Na2S. Na is an alkali. So it is aqueous. So you'll notice that sodium and sulfide are still floating around aqueous. They are not together as a solid. But our other product, KNO3, we have an alkali and we have a nitrate, so that's also soluble. So the Ks are still floating around by themselves. The NO3s are still floating around by themselves. Did anything actually react here? Did we get any new product forming? No. So there wasn't actually anything formed, so there was actually no reaction. We just mixed things. This was just mixing. Nothing new formed. You can have a situation like we saw in our demonstration here. We take our outside ions, we take the Na and put it with the NO3, and we get NaNO3. Then we take our inside ions, the Ag, and we put it with the Cl. And remember, we go backwards so that we're writing our positive ion first. Okay, and you can see that Ag with Cl, if you look on your blue sheet, it is a solid. What looks different this time? We've got ions floating around, free floating ions. We have free floating ions. What do we see that's different? We see a solid. This is AgCl solid. What do you think that little writing PPT stands for? PPT stands for precipitate, yes. So we would have a precipitate of the AgCl, and the NaNO3 would still be dissolved in the water. Now it is possible, copper sulfate is soluble, so it's aqueous. Strontium hydroxide is also soluble, so it is aqueous. But if I take copper and put it together with hydroxide, that's a solid. And if I take strontium and put it together with sulfate, that is also a solid. And you can check that on your blue sheet if you want to. But look at this. Are there any ions floating around anymore? No, everything is a solid. We have two precipitates. Now, how are you guys feeling about this whole thing? Do you feel like you'd be able to predict some products, or do you want any more examples? One more? Or no more? One more? Okay. Oh, and now I have to go back to the other thing. This is 6.3e. There we go. Or no, F. There we are. Okay. There we go. I'm going to write this one up here. We have BAS plus CuSO4. Actually, I'll write it over here. BAS aqueous plus CuSO4 aqueous. You have to take your outside ions and combine them. But before you combine them, you must know their charges. Yes? Ba is how much? How much charge? 2. Sulfate is 2. So in this case, it's actually okay to just write BaSO4. What if I had had barium and chloride? Then I would have to say BaCl2, okay? Always important, so write out your ions. So write out your outside ions with the charges and make sure you balance the charges. Now we have our inside ions. What is the charge of copper here? Copper is 2+. How do we know it's 2+? Because SO4 was 2-, okay? And we know that sulfide is 2-. Oh my goodness, this couldn't get easier if we tried, right? Because that's just CuS. And now we go check our chart. Barium sulfate and copper sulfide. Sulfate with barium is low solubility. So we are going to say sulfate with barium is low solubility, therefore it is a solid. Copper sulfide. Let's look up sulfide. Sulfide is here. Let's see if we can find copper. Do you see copper anywhere in here? No, therefore where is copper? Copper is down at the bottom. And so that's also going to be low solubility. Oops, I did the wrong thing there. I wanted to go here. So then we will write CuS solid. So you do 1, the outside ions with the charges. 2, you do the inside ions with the charges. Make sure the charges always balance. And then you check your blue sheet for the states of the products. And you balance the reaction. So number 3, you can balance the reaction. And 4, you can check your blue sheet for the state of the products. Is good? Okay. So there's more examples here if you want to read through them. But I would like you to how about we just do page 73? Is that doable? Well, that's what you should be doing, actually, right? You can do the other.